Hello and welcome to the PSEO Coalition's third webinar for our summer webinar series, Advanced PSEO Data Use, APIs and Data Integration for Deeper Analysis. My name is Annika Manny. I am the Engagement Manager for the PSEO Coalition and also the President and CEO of EDUPM. And I'm joined by our presenter today, Christopher Pena, who's the Assistant Professor of Practice at the University of Denver and also our intern supervisor for the PSEO Coalition. We're really excited that you're joining us here today. And if you've joined any of our prior webinars, welcome back. And if this is your first one, welcome. We're really happy to have you today. I'm going to turn things over to Christopher.
All right, thank you, Annika, and welcome to everyone. Thank you for joining us this afternoon. We really appreciate the opportunity to share some additional information about the PSEO dataset with you. Let me go ahead and skip forward. As Annika mentioned, this is the third in our three-part series for this summer. We've spent a couple of webinars talking about the PSEO Explorer itself, and then also some key considerations that you might need to know about if you want to work with the data in more detail. Today, we're going to go a little bit more technical, and we're going to talk about two major topics. We're going to first talk about some companion or supplemental data sources that you might be interested in using in conjunction with the PSEO dataset. And then we'll spend a good amount of time focusing on the PSEO API. That's a third way that you can access the PSEO dataset through their website. And we'll get into some of the more details about how you would do that and some key considerations if that's an option that you want to explore. So the plan for today is to briefly talk about why we need data pipelines and data analysis. I'm sure most of you are familiar with these basic principles, but I thought it'd be a good place to start. Then we'll talk about some of those supplemental data sources, specifically IPEDS, the living wage calculator, and data from the US Census Bureau. And we'll talk about three different ways to obtain data using those different data sources. And then finally, we'll talk about using the PSEO API to get PSEO dataset. And I'll have a demo at the end where we'll show some Python script that our interns have built to actually use the API and show you what that would actually look like in practice. So my goal for you today is to learn a few things. First off, I'd like you to be able to identify some relevant sources for analyzing post-secondary outcomes. Again, I know most of you are familiar with some of these major data sources. I'd like to talk with you and help you understand how we can use APIs to access structured data. We'll talk a little bit more about that later today, and how that differs from options like bulk downloads or web tools. We'll talk about how to integrate post-secondary outcomes data after we've downloaded it or accessed it. And then we'll just talk about how we can use Python to generate a workflow and a pipeline to actually work with that process from an automated perspective. So why do we need data pipelines? Well, first off, we need to know what is a data pipeline. It's very simple. It's just an automated series of steps that's designed to move and transform and process raw data from various sources into a usable format at a destination. So basically, we're just moving data from one place to another, and we're potentially doing some transformation along the way. And I'm sure many of you have already done this in some fashion in your own work, especially those of you who work in the IR and IE space. You know that there are so many data sources that we have to work with, and we want to bring them together into a single data source. So just as a simple example, let's imagine that you've got an IR analyst, an institutional research analyst, and they're doing some peer analysis, and they'd like to look at some key indicators like retention rates, graduation rates. Well, obviously, we would turn to something like IPEDS. I'll talk more about that in a minute. But we would turn to some source like IPEDS, and we want to bring those together into a single data set. And then we could do our analysis in our tool of choice. So data pipelines are really important for us, especially in the analysis world. Now, one of the things you want to think about with a pipeline is what is the process that you're going to use to get to that endpoint. And we often use something called pseudocode. If you're not familiar with that word, it might sound technical, but it's really not. It's just a way of us describing the steps that we're going to take to get from one location to another with respect to our data. So why would we use pseudocode? Well, first off, it clarifies our logic. It forces us to put down on paper the steps that we're going to take to actually move our data around and transform it. And that in turn allows us to make a plan before we actually get to the coding piece of things. And so that allows us also to communicate our steps and our logic to other stakeholders, maybe project partners. And it also allows us to debug our code by identifying pain points where things might be breaking down or not operating the way that we're expecting. So let's talk about one of the main data sources that we would likely use in conjunction with the PSEO Explorer data, which is IPEDS. Now, most of you are probably familiar with IPEDS, probably those of you in the IR space more than others, but IPEDS is the Integrated Post-Secondary Education Data System, and it's essentially a repository of data that institutions submit every year around a wide variety of data. So think about things like fall enrollment, admissions, student financial aid, and so on. We have a world of data that's at our fingertips, and we want to find ways to access that information. Now, there are a few ways that we can do that. One of the easiest ways is through web analysis tools. So you can go to the IPEDS Data Explorer website, and you can actually build your own tables of data that are interesting to you. You can also download custom data files. So we have different pieces of data that you may want to analyze. And so you can bring down that data. And then you can also download the complete data files. I'm going to show you that a little bit later because I think that's what we often do in IR. We want to actually work with the complete raw data set. And then finally, you can access the information through an Access database that's been provided through the Department of Education. And by the way, just as a side note, if you have any questions, please feel free to drop those in the chat. We're going to have a pause point a little bit later where I'll answer some questions along the way. Annika will be monitoring that chat to keep those going. And then we'll have a time for questions at the very end as we wrap everything up. So how would you get to the IPEDS data center? Well, you'd go to their website, and there's a section for the complete data files. And once you're on that page, you can actually select a particular survey of data. Here I'm showing institutional characteristics for 2023. And you can see that there are actually several different files that you can download. The file called HD 2023 is what we're interested in here. That has directory information. And that might be useful for things like distinguishing between 2-year and 4-year institutions or public and private. That kind of information is directory information. That data file is a zip file that you can then download and unzip and then extract the raw data. Notice too on the far right, there's a dictionary. That file has all of the codes and values and labels that you would find in the data file itself. So how would we actually do this? Well, let's think about it step by step. Kind of seems pretty simple, and it really is, but it's good to get it down on paper. Basically, we'd want to get the URL, the web link, to go to that file, that HD 2023 file. We'd download the zip file from the website. We'd unzip it. We'd extract the CSV file inside of it. We'd delete the zip file to clean things up. And then we would read the CSV file data into something like a pandas data frame in Python. Now, if you want to take it even further, you could actually automate even more. You could build a web scraper, a tool that actually runs through the website to get a dictionary or a list of all the different URLs for data that are available. And then you could run through that and download all those files in an automated fashion. So there are lots of different ways that you could expand on that. What you see here is a sample of some of the codes that our interns built to actually do just that, to combine the data from the IPEDS Institutional Characteristics Survey along with the PSEO dataset. I know it's a little bit small here, so after we finish the webinar and after the materials are posted on the PSEO Coalition website, we'll also have a file that shares this code with you in its complete form, so you can use that as you need to in the future. And what you can see here, if you're able to read through it, is that we're just following those steps that I outlined earlier. This is all in Python, by the way, but you could do this in another tool of choice, like R or VS Code, whatever you're comfortable with. Okay, so once you have the IPEDS data, how would you actually merge it with the PSEO data? Well, to do that, you need a join field. You need something that they share in common to bring those record sets together. If you're familiar with relational databases, then you know that when we have two tables, we need a similar column that we can use to join those two together. In this case, the join column is going to be the OPEID. That's the financial aid identifier that institutions receive from the federal government. And that's because in the PSEO data, the OPEID is the unique identifier for institutions, not the unit ID that you might be familiar with from IPEDS. So to merge the data together, we would download the IPEDS Institutional Characteristics Survey data. We would join the institution column from the PSEO dataset to the OPEID in the IPEDS Institutional Characteristics Survey, and that would allow us to create a match between the two datasets. Now, if you want to join additional data, maybe retention rates from the fall enrollment survey in IPEDS it gets a little bit trickier. Because we don't have the OPE ID in those other data files, you have to use the unit ID, the IPEDS unit ID, to crosswalk back to the institutional characteristics survey, which does have the OPE ID, and then join that back to the PSEO dataset. So it's not terribly complicated, but you do have to think through those steps, which is why I think breaking everything down is a really good approach to building your code. Now, a second data source that you might be interested in is the living wage calculator. This is coming out from MIT. Now, there are many different ways of capturing cost of living indicators. This is the one that we chose to use from some of our work for the PSEO Coalition. And it's not to say that it's the best option, it's just the one that we selected based on our stakeholder needs. What the living wage calculator does is it estimates the local wage that a full-time employee requires to cover the basic needs for their family wherever they happen to live. And there are 3 levels of analysis for data that we have available. There's state, county, and metropolitan statistical area, or MSA. That's roughly equivalent to a city or a major metro area. So how do we do this one? Well, it's not so much downloading a file, it's actually scraping it from a website. And some of you might be familiar with this from other tasks that you have to do where you want to get raw data from a website and you don't have a download file to get. Now, this is really great for us because the URL to all the different files, all the different data are very predictable, and that's perfect for automation. So what you see here is I've gone to the Living Wage website, and there's a directory called states. So we've got all the state data. And then within that, there's a directory for each of the states based on their FIPS code, the FIPS code. You're probably familiar with those. Those are geographic codes that are used by the federal government to identify geographic regions. 08 is the code for Colorado. So once we understand that, we can build the URL to actually go to the website. And once we go there, we can find that we have pages for counties and pages for metropolitan statistical areas. Once we get to the MSA page, we can see the actual table of data. This is what it looks like. Now, there are 3 groupings for different family sizes, and underneath that, there are groupings for children, the number of children in a family. And then the first row of data, I should say, is the living wage. And that's an hourly rate, which has to be converted with a little bit of math to an annualized earnings or salary. So that we have to do a little bit of math once we get the raw data. So a lot of steps here, not going to go through everything in great detail, but basically we need to get a list of the URLs, the web links to get to the pages. We're going to get a list of states and their corresponding FIPS codes, use that to build those URLs, go to those websites, get the MSA links, cycle through those, and extract all the data from the tables on those pages. Again, this is an excellent candidate for automation because while we as people could certainly do that work, the computer can do it a lot faster and gather much more data more quickly for us. And this is just an example of what pseudocode could look like for this task, getting a little bit more technical. Again, once you get the slide deck, you can take a closer look at this. But this is where we start to integrate some additional pieces like number 4, set headers to simulate a browser request. Basically, that's just us telling the website that we look like a web browser so we can extract the information from it. A little bit more technical detail there. No, it's very small here, but this is some sample of the code that would allow us to get the living wage information from that website. And what we've done is we've created a module that we can then call to run through all those pieces that I just described for you. And you can see a few things like we're trying to identify the table structure and exactly where to go, because we as humans with our eyes can tell where the data start. We have to tell the computer how to do that. So there's some logic built in there. And then we're naming the columns things like 1 adult, 0 children, 1 adult, 1 child, to label all the data that we're capturing. Once we have the living wage data, we then probably want to join it back to the PSEO data. And more than likely, you'd probably be joining to the state of the institution that you're looking at in the PSEO data. So in this case, we would actually want to join on the ID of the state in some fashion. There are a couple of ways you could do this. The way that we chose to do it with the interns was we're going to take our PSEO data set and we're going to merge it with the label institution CSV file that's provided by the US Census. That provides institution codes and state codes and FIPS codes, so all the state information. We're going to take that, merge them together, And then we're going to merge that updated PSEO data set to the living wage data and use our state columns as a join column. So that will allow us to merge those data together. Again, different ways that you could do this, but you need to get to a point where you have a join column between the two. All right, and then let's wrap up with the US Census Bureau. Now, we all know that the US Census Bureau provides a lot of information to us around demographics, in our case for post-secondary outcomes. Earnings by educational attainment is probably particularly interesting to us. There are different ways that you can access the data. There's a table builder that you can use through their website where you can access all the different tables of data and select the variables and filters, do all the things that you'd want to get the data that you need. You can use a website like IPEDS. This is a website that takes together public data sources and makes it more accessible to people. You can have a lot of detailed control over the variables that you select and exactly which criteria you want to use. So that's really helpful, especially if you're doing research where you need to be very specific about your definitions. And then finally, we have an API, which I'll talk about in just a minute, which is another way that we can access the information more programmatically. What is an API? Well, an API is an application programming interface. It's just a set of rules and tools that allow software to talk to each other. So this is exactly what we want to do. We want our computer to talk to some data repository, retrieve the data, and come back to us. Very often, API return data in what's called a JSON format. This is a special kind of data, I'll show that in just a minute, that is not structured because it's not using columns with rows like a table, but it does have structure to it. So we call it semi-structured. It's kind of nested in a hierarchy, if you can imagine that. The basic components of an API are a request. We're calling the data out, and we use that with a GET request. And then we get a response, what we get back from the data repository that we're calling to get our data from. This is an example of what a JSON file looks like using an API as a URL. And some of you may actually be familiar with this. You might have sometimes seen a web address when you call for data in some fashion, maybe through a visualization tool, something like that, where it's got get equals, and then a variable name, and then we've got another variable name, and then the ampersand, and then 4 equals US:1. Looks kind of cryptic, but it's actually really easy to parse. We're getting a couple of variables, and we're specifying, in this case, for the whole United States, the geography of 1. So that's going to be the for clause. What you see in the image below is what a JSON file looks like. And you can see the first element, 0, is going to be our labels, kind of like for a table. And then after that, 1, 2, and 3 are elements for specific institutions. We're getting the median earnings at 1 year, we're getting the label for the institution, and then the geography for the for clause that I just mentioned. So why would you use an API? Well, the main reason is you can get fresh real-time data. You're actually calling the data live whenever you run the request. So if you have data that frequently change over time, an API might be really good for you. In fact, many of the apps that you probably use today, like a weather app, they're going to use an API to call that data when you click your refresh button or when it first opens. So it's really powerful when it comes to that. Now, on the flip side, if you have data that don't refresh very often, maybe a couple of times a year, like the PSEO data set, you kind of have to decide if the API makes sense for you. So what are the other reasons you might use an API? Well, a big reason is automation. This is one where you can actually automate steps to get to the data and transform and modify it as you need to. It's also really good because it gives you selective access. You only have to pull down what you're interested in. And then it gives us consistency and standardization. Because we're pulling from an external data repository where the data rules and cleaning have already been set up, we can pull down trusted and reliable data for us to work with. It's also highly scalable. That means that as our tools start to grow and our data needs with it, we can actually expand our use of APIs. I don't have time to show you this today, unfortunately, but you can integrate APIs with tools like Tableau and Power BI so that you have very robust data analysis tools in your toolkit. And then finally, you have access to dynamic services. Now, this depends on the particular data repository that you're calling from, but basically, you don't always have to get just data. You can sometimes do processing on the server side of things. So it takes a bit of the load off of your computer or your internal server. Now, before you begin using the census dataset, you do have to request an API key. This link will be provided in the slide deck and in some companion links that we'll provide after the webinar. Very easy to request. It's a free service, and it usually turns around really quickly. I think I got my API key the first time within the same day, so you should be able to get started pretty quickly. You basically just need to provide some basic information, and then you can request the key for any kind of use that you need for your work. So this is an example of how we might use the API for US Census to get information like the median earnings for high school graduates by state. We would want to import our required libraries, define our key and survey year. For most of this, we're going to use the 2023 year. We'll define our base URL for getting the data, define our parameters, use the API to call the data, and then I like to write my data to a CSV file. You don't always have to do this, but as you're getting familiar with an API tool, I think it's a good best practice to write your data out and examine it external to your code. One of the challenges I often see with my students, and I think practitioners as well, is it's very easy to get mired in the code and not double check your work, especially when you're getting to know a tool. So I'd highly recommend that you write it out, examine the data, and make sure that you're getting what you expect. This is a sample of what the code to get the US Census data could start to look like. We're declaring a couple of variables like the year that we want to pull and the URL where we can get it. See that api.census.gov. Then we're going to define the parameters for retrieving the data. We need a get clause. So which columns do we want? There's one column there along with the name. 4 gives us the larger grouping, typically geography. And then the key is just the API key, which for obvious reasons I didn't want to show here, my personal key. And this is the API itself. I'm going to go through this in more detail when we hop over to the demo, but this is what it could look like. And if you're not familiar with Python, it might feel a little bit overwhelming, but just remember that we're following those steps. We're breaking them out. I tend to use Jupyter notebooks to write my code because you can break things out step by step by step, and it makes it really easy to do things piece by piece instead of all at the same time. And all we're doing is calling the API using the parameters that we defined earlier and the URL that we defined as well. We're telling it what we want to do. We're reading it into a data frame, which is a Python data structure, very, very similar to a table. And then we're writing that out to a CSV file. And that's it. That's all we're doing here. So a very, very straightforward process. Okay, let's assume that you got those data from the US Census, median high school earnings for high school graduates. How would you actually join them back to the PSEO dataset? Presumably, you would want to do it on the state. You'd want it for the same state of a given institution. So the process is very similar to what we saw before. You would need to get the state information for a given institution. So you get the state code or the FIPS code, and then you could join that to the census data on a state column of some kind, depending on how you chose to pull the data. So a simple process, but you would need to pull them down and then merge them together to do your analysis. All right, let me briefly talk about the PSEO API, and then we'll pause for some questions. Now, we can actually use an API to access both the earnings and the flows data. What you see here is the list of variables for the PSEO earnings data set. And we have the qualitative labels and codes at the top. And then at the bottom, we have our quantitative measures like the number of students in the cohort or the earnings at 1 year, 5 year, and 10 year, and so on. We also have similar variables for the flows data set, but this time we now have things like the NACE industry code, which are relevant to the flows data. We also have some additional data for geography. Those of you familiar with the flows data know that it's a little bit different from the earnings data set. We'll provide the website where I got this information, but you can just do a quick Google search for PSEO API, and the site will come up where you can actually see all of the variables that are possible in the PSEO API. Now, this is a sample of code for the API for the PSEO dataset. I'm going to show this in our demo in just a little bit, but in this case, I wanted to get information for a particular institution, a community college here in Colorado where I work. So all we're doing is we're defining a list of fields that we want to get back from our API. We're defining the parameters that will run the API. We're sending that out as a request, and then we're reading the data back as a JSON file. We're inserting that into a data frame, and then we're writing that out to a CSV file. So again, same steps that we've learned about earlier today. Now, you might notice that I was using the institution code, the OPEID. And so your question might be, well, where would I get these codes from? Especially if you think about things like degree level codes or state codes, the FIPS codes, things like that. Well, you can get this through the metadata for the PSEO Explorer itself. If you go to the PSEO Explorer homepage, in the upper right, there's a link for help. And if you click that, it'll take you to this page, what you're seeing right now. On the right-hand side of that page, there's a link for PSEO data schema for most recent release. And that's what you want to click on to get a list of all the variables in the PSEO dataset. And for each one of those where it's applicable, there will be a CSV file that you can download that has the codes and the labels or descriptions that go along with them. So especially if you're trying to look up a particular school, or if you want to know the degree level codes, for example, as you work with the data, you'll become familiar, but until then, you might need to look up the list of codes, so those are publicly available. A few things that you want to keep in mind if you're using the API for the PSEO dataset. First off, this is programmatic, so you need to make sure that things are precise. So your variables need to be identified correctly. They have to be exactly the same as they're listed in the documentation. You also want to think about how you want to filter the data. We'll see how we can do that in just a minute, and which variables you want to use to do that. You might want to consider that it's possible that no data will be retrieved. That doesn't mean that the API isn't working. It just means that there are no records that match the criteria that you defined. And typically you need to specify a geographic clause. For us, it's typically going to be the for clause, and in this case, US1, which is the whole United States. Now, a few additional things to know about the PSEO API. When we start to build that out, you can specify which columns you want to see. You don't have to see everything. But if you don't specify certain columns with a filter or a grouping variable, then it'll default to certain records. So I listed a few here that are important to know about. First off, the degree level. If you don't specify a degree level, just like the PSEO Explorer, it'll default to 05, which is the bachelor's degree. Maybe that's what you want, but maybe not. The grad cohort defaults to 0000, which is the placeholder for all cohorts. And then the zip code defaults to 00, which is the level for all instructional programs. So you have a few of those built in. So as you're pulling data, just keep those in mind. If you don't specify them, that's what you'll get back, not the entire data set, those particular records. And a few best practices to keep in mind as you're working with the API. The first one, this is what I recommend to all of my coding students. Start simple. Start at the core of what you want to do and build out from there. The reason I recommend this is because if you try to go too far too fast and you hit an error, it can be hard to figure out where things went wrong. But if you start small at the core and you build out from there and you do it step by step, you build, add something to it, test, make sure it runs correctly, add something new, test, and you do that iteratively. If you encounter a pain point or a problem where things aren't working the way you expect, then you know that it was that last thing that you did that caused the problem. So that can help you really narrow in on where things might have been a problem. I would highly recommend that you include your labels when you download the data through the API. The reason for that is because until you're familiar with the codes, it can be a little cryptic. And so that can help you to troubleshoot as well. And then finally, just be prepared for the possibility that you won't get data back, especially as you start to play with complex filters. You may not get any records back that meet those criteria. So just a few things to keep in mind as you're working with the API for PSEO. All right. Before we move on to the demo, let's pause for a few minutes and see if we have any questions. I see a few highlighting in the chat. Annika, was there anything that popped up for you that we should talk about?
Yeah, Cecilia had a great question. She said, many of us work with data that contains PII or personally identifiable information. What cybersecurity considerations should we take into account when we're using APIs to make sure we don't put our agency data at risk?
That's a great question. I don't want to punt this question, but it really will depend on your organization's IT processes. So typically you'll have internal processes and safeguards that are built in to answer exactly that problem, especially if you're dealing internally to share data in different ways. And if the data are being posted publicly, like the PSEO data, then they would have already gone through that vetting, cleaning, and de-identification process so you don't have to worry about that on that side of things. But when you're sharing data maybe with a colleague or you're building something, let's say for your organization internal, that's really a conversation to have with your IT partners to make sure that they're setting that up. You can often de-identify to a degree. So maybe you still keep it at the micro data level, like a person level, but you take out identifying information, obvious ones like the student ID, the social security number, things like that. And then sometimes like the PSEO data, you can aggregate up to an aggregation level, and then you make some decisions about cell sizes, like 30 is a really common one. If it's less than that, then you suppress the data. So that's how we would typically handle it on that side of things.
Thanks. And then we just had a question clarifying that there was, in fact, a PSEO API as one of the Census's APIs.
Yes.
And I think it would be great. I think you said you would share the link. So when it's appropriate, if we could share the link to that page, that would be great.
Yes, the plan for today was we're going to have all the links together in a document that we'll share along with the scripts that I've shown you today. So you'll be able to go to those links directly and explore.
Perfect. That's it.
Okay, well, that's easy enough. Thank you. All right, let me hop over to my Jupyter notebook. So just give me a minute, please. All right, so you should be seeing a Jupyter notebook right now. And this is a script that we built for capturing PSEO earnings data using an API, so the PSEO API. Just above it, I have a variable that I've declared with my key. Obviously, I'm not going to show that again just for security reasons, but let's assume that it's already been read into our notebook. And the reason I love Jupyter Notebooks is you can do things step by step, process-wise. So it's really great, especially if you're first learning Python or if you're building up your skills. Makes it a little bit less intimidating than writing a full Python script. So I just wanted to go through some examples here and show you what it would look like and what are the components that you would need to include. And again, we're going to provide this full script for you after the webinar so you can tear it apart yourself and then modify as you need to. So the first thing is we need to define our URL. So where are we actually going to get the data from? That's the API website. Then we're going to import our required libraries. We're going to use request to actually do the API call and pandas to do our data manipulation. That's where our data frame will live. First off, we probably want to get to know the data a little bit. So let's say that we wanted to get a list of all institutions in the earnings data set. Don't really care about all the other data for right now. I just want to get a list of institutions. So first off, I'm going to define my fields, which are the institution and the label for the institution. Then we need to define the parameters that are going to go into the API call. So we've got our get clause, our for clause, and our key, which references the variable that I defined earlier, so I don't have to keep showing my key. Now, one piece that you may notice here that might look a little bit funny to you is what's going on with the get statement. Now, in order to use get, you need to provide a string with a list of the variables that will be used to call the data from the API. Now, you can actually put those together in a long string. In this case, I just have institution and label institution, so it's not very long. But as a best practice, I recommend you take your variable names and put them into a list like I did before with the square brackets, and then call those values into your get clause. What I'm doing here is I'm using the join method on that list of values, and I'm joining them together. I'm concatenating them together and separating them by a comma. That's where that comma comes in at the start of the join. That's all it's doing. It's just concatenating them together to create a long string. Then we need to send the get request. So that's going to be the next step. And that's where we get a variable back called response. And then we're going to check that response and we're going to see, did it work okay? That's response status code 200. And if it did, we're going to proceed to the next steps. We're going to read the data from a JSON format. So that's a method that we can use in Pandas. We're going to read it into a data frame. And then we're going to write everything to a CSV file. And then finally, we'll show the first few records using the head method just to view our data and make sure everything looks okay. So the output below that shows me a list of all the institutions. Remember, we have that category for institutions in a state. So that's what shows up first. And it's just going through alphabetically through the list that it's retrieved. If I were to look at the CSV file, then it would show the entire list of institutions in the PSEO dataset. Let's say that I wanted to narrow that down a little bit further, and I wanted to get a list of institutions in Colorado only. So how would I do that? Well, copy, paste, modify. That's going to be your best friend here. The only thing that's really different is I've added a parameter for the institution state. That's inst state is the variable name. And after that, after the colon where I define the value, it's 08. That's the FIPS code for Colorado. Remember I said earlier that you would need to look up those values from the PSEO Explorer metadata website. So that's where I got that from. Otherwise, it's exactly the same. And now I can see that I get a list of all the institutions in the state of Colorado. Okay, let's say that I wanted to get some information about one particular college, and I just chose Arapahoe Community College since they're one of the first few that show up in the PSEO Explorer. In this case, I want to get the institution, the code, the name, the state, and the name of the state. So in this case, instead of the state code, I'm going to define the institution code, and that's going to be the OPEID for this particular school. And if I do that, then I get one row for Arapahoe Community College. I know it's broken across what looks like two rows, but it's actually one row of data. Jupyter Notebooks just breaks it apart for readability. Okay, so that's a basic introduction to how we would call the API to get the information. Let's actually get some real data to work with it. Let's say that I wanted to get the median earnings, so the 50th percentile at 1 year for this particular school. In this case, I'm going to modify my list of fields to include the year one P50 earnings. That's the median earnings at 1 year. It's keeping everything else the same, so nothing changes. And then I'm going to get one record back and look at the earnings. It says none. Okay, well, my first instinct might be there are no data for that particular record, and that would make sense. So let's explore a little bit further. Let's say that I add degree level to the list of fields. That's going to be the degree level code, not the label. So I've added that up above, and everything else is the same. And then if I scroll down, I can now see the level codes 1, 2, 3, and 5. And notice that 5 shows up as none. Remember I said earlier in the presentation that if you don't define the degree level, then it defaults to 5 or the bachelor's degree. And that's what happened in the earlier chunk where I didn't define the degree level, so it defaulted to bachelor's, which returns none. There is no data for that particular record in the PSEO dataset. There's a record, there's just no data in that cell. Now you may also notice that I've got two columns for institution. And this is just a quirk of how the API process works. If I scroll back up a little bit, you can see that I've got the institution in my list of fields, and I've specified it as a filter in my parameters. In that case, I'm going to get two columns back. They're the same data, same values, it's just duplicated. So how do I get rid of that? Well, it's very easy. In this next chunk of code, we've just added one extra element, and that's going to allow us to drop the duplicated columns. This is just a way to tidy up your data set if that's important for you. Of course, if you want to keep those duplicated columns, you don't have to do that. But for the rest of the examples, we will show that. All right, let's say that I only want to get data for associate's degrees. This is a community college, so that makes sense. We know that they didn't have data for bachelor's. So in this case, I'm adding a new parameter, a new filter on degree level, and the code is 3. That's the code for associate's degrees. So you'll notice the basic pattern is all I'm doing is after the get clause, I'm adding the variables that I want to filter on, and then I'm specifying the value. You do want to be careful about these numeric values or ones that appear to be numeric. Notice that they start with leading zeros, 0, 3, 0, 0, 1, 3, 4, 6, 0, 0. So you want to make sure that you enclose those in quotes, either single or double, to make sure that Python reads it in as a string and not a number. With graduation cohorts, it's a little bit different. You can treat it as either a number or a string, although it gets a little bit finicky with the all cohorts 0, 0, 0, 0. Basic data management that you have to think about when you're reading the data out. Otherwise, exactly the same. And now we can see we get one record back, and that is for the bachelor's degree. And it looks like the median earnings at 1 year was about $44,700. Okay, now what was missing? Well, let's add the graduation cohort. So now we've added grad cohort after the degree level. Everything else stays the same. So again, copy, paste, modify. And then we can see that we now have the graduation cohort starting with 0, 0, 0, 0. That's going to be the all cohorts. Now, I know it's a little bit funny, but this first record in the second row corresponds to the first record in that top row. And so 44,725, that's the number we saw before. That corresponds to the grad cohort 0, 0, 0, 0, which is all cohorts. Okay, let's add our SIP codes because that was also missing. So now we've added our SIP level, our label for that. Remember that distinguishes between 2-digit and 4-digit SIP codes. Our SIP code itself and the label that goes along with it. Everything else stays the same. And now I'm going to get more data back. So I can see that now I'm getting all of the SIP code values and all of the SIP code levels along with it. So that might be helpful for me to do analysis on a deeper level for the programs. Okay, what if I wanted to specify just instructional programs altogether and for all graduation cohorts? We're just going to follow the same model that we saw before. I've got a parameter for institution, one for the degree level, and now I've added one for SIP code. 0, 0 is for all instructional programs, and 0, 0, 0, 0 is all cohorts. Otherwise, exactly the same. And then from there, I get one record back for all cohorts, for all programs, and that's 44,725. That's the number that I saw before. So again, you don't have to specify these values, but just be aware that there are defaults that will appear if you don't specify them. Okay, let's try a deeper question. What if I wanted to add a second institution to my list? So far, I'm just pulling one institution, but chances are I want to do some peer analysis or some benchmarking. Well, using the logic that I explained up above, your first instinct might be to say, well, what if I create a list of institutions and I put the OPEID codes inside of that, and then I make a concatenated list of that, and then I use that as my filter for institutions, just like I used in the get clause to get all the fields that I was interested in. Unfortunately, that doesn't work. Most APIs will not accept multi-valued string characters. So if I were to run this request, I would get a very sad error 204, which basically tells me no data were retrieved, no records at all. Now you have to be careful here because it could be that your filters are not set correctly. There's no intersection there for records to be retrieved. In this case, I happen to know that it just won't work from a programmatic perspective. So how would we tackle this problem? Well, we can actually use a for loop. Those of you familiar with programming are probably very familiar with the idea of a loop. But basically, all we're going to do is define a list of institutions. We're going to create a placeholder for all of our data to be merged together. And then we're going to cycle through that list of institutions, and we're going to run the process that we defined up above. So here's what's happening. For inst in institutions, basically for each value in the institutions list, run through this API, collect the data using the parameters that we've defined, and then take that data and add it to the all data frame. And then we're just going to run through that process until we meet all of the institution lists. And then we'll write the data out to a CSV called final DF. That's the final data frame. And now when I run it, I've got two records, one for Arapahoe Community College and one for Adams State University, the second one that I wanted to look at. So using the API is pretty straightforward. I know seeing the code can be a little bit overwhelming, but the steps are not too complicated. And I will be honest here, if you're not skilled at Python or if you're still learning as a language, generative AI is a great tool to help you out. It doesn't solve every problem, but it's a great starting point. So something to consider as you're troubleshooting your code and as you're building your code, use it as a thought partner, especially when you're hitting an error and you need to understand why that is. All right, so that is the demo. I'm going to hop back over to our presentation slide deck, and then we'll take a minute to answer some additional questions. All right, so up here on the slide deck, we have a QR code to a survey that we would love for you to take a few minutes to fill out. It should only take a couple of minutes. And as we've done this webinar series, we'd love to get your feedback on how it went, what worked well, maybe some room for improvement, additional topics that you'd like us to discuss in the future. So if you wouldn't mind taking a few minutes to fill that out, we'll also have this in the slide deck afterwards if you want to take some time later on. But we would appreciate hearing your feedback, especially constructive feedback, so we can make these webinars as strong and useful as they can be for you in the future. All right, that's everything that I wanted to share with you. Annika, did we have any additional questions that came up?
I don't see any questions in the chat. So please, if you do have a question, feel free to put it in, or we're not a huge group right now. So if you want to just unmute and ask a question, that's fine too. Just raise your hand so we can call on you, your virtual hand. And then, so Christopher, maybe while we're waiting to see if we have any additional questions, do you want to share a little bit more about like how you guys have used the APIs to do some of the data, like with the work with the interns to create dashboards and different tools?
So far, we haven't explored it that extensively for production. We were given some specific projects over this last year with our 2 student interns in terms of developing some interactive tools, which hopefully many of you have seen on the PSEO Coalition website. There are 3 tools that are out there right now. But that would be a next step for us because there is that API integration with Tableau, which we're using for development that I mentioned. So I think that'd be really interesting to work with. The challenge is the data are refreshed twice a year-ish on the census side of things. And so there's not a heavy need to refresh the data periodically. So day to day, for example. If we were talking about other data sets, then it might look a little bit different. But that's just not something we've fully explored just yet because there hasn't been the business need for it so far.
Okay. Not seeing any questions or hands raised. So unless there's something else that you'd like to share, maybe we can just move to wrapping up.
Sure. All right.
So
Oh,
we thank you so much, Christopher. This was really informative and amazing. And like Christopher said several times during his presentation, all this recording from today, his slides, copies of the code, and a document with all of the various links that you might need to access these different data sets will be provided on PSEO's website on our events page, which is the link that you see on the screen right now. And we would love to invite you to our next PSEO event, which is our virtual showcase coming up on September 24th. It'll be from 2 to 4 p.m. Eastern Time. We will be showcasing the dashboards that have been created and some research studies that have been done using PSEO data. So if this PSEO data stuff is exciting to you, I think you'll really enjoy our virtual showcase. So please take some time, go to the events page, register for that, and we hope we'll see you all there. And I'll just put a link to that in the chat as well. Yeah, thank you, Emily. She mentioned if we search on the Tableau public for PSEO, there's several dashboards created by different states and institutions. And we've also been sharing some dashboards on PSEO's website as well from our various member states. So you can see lots of different examples of how folks are utilizing this data and matching it with other data that's relevant to their state and context. Awesome. Well, thank you very much. Thanks, Christopher, again. And thank you all for being here with us today.